Hi, today's lesson is about inverse normal probability, finding x with negative z-scores. So we've talked about, just a reminder, normal distribution is when we go from the x real world value, find a z-score, and then the probability. Inverse normal is when we go the opposite direction. We have the probability, we need to go back and find the x value. So today's problem we're going to look at is Jono's daily run times are normally distributed with a mean of 23 minutes and standard deviation of 2 minutes. 75% of his runs are longer than what time? So the key thing is we should recognise that 75% has been put in there. Obviously we don't think of it as 75%. We think it is 0.75 for the purpose of using our table. The other key things is we've got our mean, we've got our standard deviation. The value we are missing is the x. So if you go through that process, it's always best to make sure whether you're doing a standard normal distribution or the inverse. So first thing, as always, draw a picture. So we've got the mean, which is 23 minutes. Standard deviation is equal to 2. What we want to know is 75% of his runs are longer than what time. So that means that our value is going to be somewhere down here because 75% is more than 0.5, which is halfway. That means that our graph, at the table, we are looking for 25 or 0.25. So this area here to work it out for 75. So the second step is to look up in the table 0.25. So if we take a look at that, so 0.2, oh no, sorry, wrong way around. So 0.25. So we can see this one here, it's 0.2518, so that's too big. We can see that one there, which is less than 0.25. So we've got 7 and 0.6. So far, Z is equal to 0.67. Now what we want to do is see the third decimal place and see if we can get close to 0.25. So 0.2486 is 14 away from 0. So in other words, 0.2500. So we've got 14. The closest we can find is 13. If we go to 16, we're going more than 0.25. So we end up with 0.499 as our probability, but that's close enough. So we're going with the 4. So our Z value, or our Z score, is, sorry, and it should be negative because it's on the left-hand side. So the Z score is 0.674 negative. So now that we've got the Z score, we need to move on to calculate the value of the score. The formula is there. So X is equal to our Z, which is minus, and the minus is really important because otherwise you're not going to get a score that's lower than the mean, which is what we want, times the standard deviation, which is 2, plus the mean is equal to 23, and then we can do that calculation, which gives us 21.652. Obviously the 652 is not in seconds, so we need to convert that. So 0.652 times 60 for 60 seconds gives us 39.12. So we're going to say it is 21 minutes and 39 seconds. In reality, it would be slightly more than 75% of his runs would be longer than that. So 75%, write your answer in context, 75% of his runs are longer than 21 minutes 39 seconds. Obviously, INVEST's normal problems aren't related to time all the time. I know in our two examples that we've done over the last couple of lessons, it has been time, but the process is always the same. So always draw the picture. In this case, we're drawing the area above a negative Z value. Look up the probability in the table. Calculate your X value from that, and always write your answer in context. So again, there's some more work to complete in the lesson page in the OneNote.